Next, we'll take a look at using set notation with quantifiers. So we can restrict the domain of the quantified statement explicitly by making use of a particular notation. For example, we can say for all x in the set S, P of x. And that is the quantification of P of x over all elements in the set S. So, for all x in the set S, P of x is shorthand for all x is in the set S, then P of x. So one's just shorthand for the other. And then we can say, similarly, for our existential quantifier, there exists an x in set S for P of x is shorthand for there exists an x where x is in set S and P of x. So we can pair this with an example. So what do the statements for all x in R, x squared is greater than 0, greater than or equal to 0, and there exists x in Z where x squared is equal to 1. So what do those statements mean? Well, the first one, this one, means for every real number x squared is greater than or equal to 0. And that is true. And this one means there exists an integer x such that x squared is equal to 1. And we can say, okay, for x is equal to 1, this is true. Therefore, the statement is true. Next, we'll talk about truth sets and quantifiers. So these tie together sets and predicate logic. Given predicate P and the domain D, we define the truth set of P to be the set of elements x in set D for which P of x is true. The truth set of P of x is denoted by the set of all x in the domain D such that P of x. We can take a look at an example. We'll say, what are the truth sets of the predicates P of x, Q of x, and R of x, where the domain is the set of integers. And P of x is absolute value of x is equal to 1. Q of x is x squared is equal to 2. And R of x is absolute value of x is equal to x. So in this case, the truth set for P, we get the set of all x in Z such that the absolute value of x is equal to 1. The set is x is equal to -1 and 1. So in set notation, -1 and 1. For Q, this is x in Z such that x squared is equal to 2. Truth set is empty. Because square root of 2, let me make that more clear. Square root of 2 is not an integer. R is a set of x in Z such that absolute value of x is equal to x and the truth set is non-negative integers n, because n being natural numbers there, because x is greater than or equal to 0. And that finishes up this section.